Yo, what's up everyone? Welcome back. Patrick here, moving on to the next calculus question. This one's going to deal with the product rule. It's pretty tricky, it's a little unique. So if f of x is equal to negative 5x minus 1, and g is a function such that the second derivative of g at an x value 2 is equal to 3, and then the second derivative of fg at an x value 2 is equal to negative 6, then what is g prime 2? What's the value of the first derivative of g at an x value of 2? So what I'm going to do here is I'm first going to get an expression for fgx. And fgx basically is the function f of x times g of x, both functions multiplied together. Now notice in the question we're given what f of x actually is. It's negative 5x minus 1. So I'm going to plug in that expression there for f of x. Now notice g of x, we're not given the actual function g of x. We're given information about it, like over here, but we're not given the actual function. So I'm going to just keep it in that general format. Now, notice that for this function, fgx, we're given the information about the second derivative of it. And we're also given information about the second derivative of g. So let's take this function here and find the second derivative of it. And before finding the second derivative, we got to find the first derivative. So notice it's two functions that are multiplying together, so we got to use the product rule. So we would take the derivative of this function, which is just negative 5, multiply it by g of x. And then we're going to take this function and multiply it by the derivative of this, which is g prime x, like that. Right? So this here is the expression for the first derivative of this function. Now from here what we can do is we can find what the second derivative is going to be, get an expression for the second derivative. So notice the second derivative of negative 5 times g of x would just be negative 5 g prime x, like that. Right? You got a constant in front of function, so the derivative is just going to be the constant times the derivative of that function. And then over here, the derivative of this, notice we're going to have to apply the product rule again, right? Because it's two functions that are multiplying by each other. So we would take the derivative of the first function, which would be negative 5, so it would be plus negative 5. You can change those to a negative. I'm just going to sort of keep it separate for now. We got this positive here. And then that function stays the same. Plus this function left as is times the derivative of g prime x, which is g prime prime x, like that. Okay, and then from here, notice that these two are like terms. So we got negative 5g prime x plus negative 5g prime x, which is like negative 5g prime x minus 5g prime x. So this could be negative 10g prime x. And then these here, I'm just going to keep separate. So we'll have negative 5x minus 1 g prime prime x. So that there is the expression for the second derivative of this function here. So now what I'm going to do is, given this expression here, I'm going to plug in an x value of 2. And I'm going to plug in 2 for all the x values here. So we'll have negative 10 g prime of 2, which is, notice that's what we're looking for. And then we'll have negative 5 times 2 minus 1, and then we'll have g prime prime 2, like that. So the value of the second derivative at an x value 2 of this function, fg, is equal to all of this. We will just plug in 2 for all the x values. And then notice that this here, we know that that's equal to negative 6. Now, this is what we're solving for, so we don't have anything to plug in there yet. Now here what we'll have is negative 5 times 2 is negative 10 minus 1 is negative 11. So we'll have negative 11 and then g prime prime 2. Notice that we're given that as being 3. And now notice we just have an equation where we have to isolate for this g prime 2. So what we would do, this would become negative 33, bring it over, negative 6 plus 33. That would give us positive 27. We'll have negative 10, g prime 2, divide both sides by negative 10. And so g prime 2 ends up being negative 27 over 10. And then that can't simplify any further. Right, so that ends up being the answer for g prime of 2.